What's going on, everybody? This is Mr. Diamond, and today we are going to be going over our first notes from Chapter 2, the periodic table. Now, you may have noticed that my audio quality is a little bit worse. Unfortunately, my mic has gone kaput, as they say. So I'll be waiting to get my new mic hopefully next week. If not, you're going to have to put up with this lackluster audio quality for another week. I apologize for that. But today we're going to start talking about the periodic table. Now, we've already worked with that a little bit, but we're going to kind of focus on reading the table and its origins here in this first section. Just as a quick refresher, an ion we talked about before is any atom that has a charge associated with it. We talked previously about how the location and arrangement on the periodic table is important. It told you things like the S block, the P block, D block, and F block, and it told you how many electrons each atom had. We also said that most chemical reactions, I briefly mentioned this, occur due to electrons. They are the cool thing about atoms. They are the most reactive thing. They are the thing that gets most involved with the world around them. So we'll talk about why that is a little bit later on as well. So we discussed that the periodic table has a lot of hidden information inside of it, and this is due to the original layout of the table coming from a desire to share more than just the names and the numbers. Like, you could have just listed all the elements, their names on like a table, like a listed table, and they didn't really want to do that. They wanted to try to show more information. And the person we have to thank for that is Dmitry Ivanovich Mendeleev, who is Russian, as I got a little Russian there at the very end. And he proposed his idea for how the table should be laid out. So he was the first person to decide that when arranging the table by elements, we should do it by properties and not by mass. He included gaps in the table based upon where he thought the properties didn't line up. And in some of these gaps, Mendeleev even made predictions about future elements. So this is the guy. Now, you might think he looks a little bit like Alan Moore if you're a comic book fan, or Rasputin if you're a Russian history fan. But he had a pretty rough life. Mendeleev was born to a family that had like 10 siblings in it. His father went blind when he was a child, so he was no longer able to work his job, and he died when Mendeleev was pretty young. His mom tried to raise him and tried to take on like a role working in a factory in the town that she lived, but the factory ended up burning down, and she knew that her son Mendeleev was this special boy. I mean, we all know that, every parent feels that way about their kid, but she knew that he had a scientific mind, and she wanted to give him a great career and a great future, so she rode hundreds of miles to a school in Russia to try to find him someplace to take him. And she showed up and was like, "Hey, my son is incredibly smart. His father was a professor at a college. Can you please teach him?" And they were like, "No. You just rode here on a horse with a child. Why would we raise him? That doesn't make any sense. Like, we're not gonna take him in." So she had to then ride another couple hundred miles, eventually to the college where her former husband and Mendeleev's father had worked, and they did finally give him a job, or give him the ability to be taken in. His mom died a couple of weeks after they arrived from riding hundreds of miles on horseback in the Russian wilderness, because, that's not a thing that most people normally survive. And Mendeleev, one of the things he was really focused on was trying to arrange the table. That was like the thing in science at the time. We were in the 1800s at this point, and I think it's the late 1800s, if I'm correct. And a lot of people kept trying to arrange them by masses. They had developed methods of weighing hydrogen and lithium and beryllium and boron and all of these other elements, and they'd found ways of weighing them. But he eventually realized that some of them had properties that lined up, and he felt like those properties were more important. So instead of trying to just list them by masses, he kind of shifted some things around, and he made a series of columns that repeated themselves. He noticed that, for example, all of the ones in this first column here that we call the alkali metals now, they would react violently with water. And same thing with these guys over here, but they reacted a little bit less violently, a little bit differently. And they also reacted at different ratios. He would take things like how they reacted with certain chemicals, how much of them were used up in certain chemical reactions, and he made predictions that, okay, well, this must be here, this must be here, and this must be here. And the real crazy part, and the reason that he is an absolute madman genius, was that not only was he willing to make these predictions, he was willing to put blank spots. So these little purple boxes here on this table, those purple spots are empty. He left them blank because he was confident that there was going to be an element discovered that would go there. In this case, he called this one Eka aluminium. Aluminium is the more international version of pronouncing aluminum. And if you look, there's zinc, or calcium is right here. And then we've skipped kind of a bunch of the transition metals in there, or a couple of the transition metals. But he thought that this element here and this element here should exist. And this, if you look on the table, after calcium comes scandium, and then after zinc comes gallium. And gallium is actually in the same column as aluminum, and aluminum's in the same column as boron, and is in the same column of indium right here. So he left those blanks, and he said, not only am I confident enough in my methods and in my approach that I think I'm right, I'm going to leave blanks and predict that in the future we will know there are elements that go in these spots. And a lot of his scientist compatriots were like, we can't even get the table, like, agree on how the table should be arranged normally. Like, why are you trying to make predictions? And he was so confident in that fact that when a French scientist discovered gallium, discovered this number 68 here, and published his information, he actually told him to go back and check because he thought he was wrong. He estimated that Eka aluminium, which he called EA on his table, would have an atomic weight of about 68, a density of about 6.0 grams per centimeter cubed, a low melting point, 3 valent electrons. They'd probably find it from its spectrum, and it would have a density of about 5.5 centimeters cubed. And it would be soluble in both acids and alkalis. So acidic and basic components. When the guy discovered gallium, I don't remember which one of these numbers it was, but I think it was either a density of the oxide or it was the density of the solid up here. But the guy reported a certain number, and Mendeleev wrote the scientist who was in France while he was in Russia and had never seen this element before, and was like, "Hey, you should check again. You're wrong." And everyone was like, the gall of this Russian scientist to try to tell me I'm wrong and he's never even seen this element. Fine, I'll check again just to prove him. Oh, I actually did measure it wrong. He was actually right. And that's how confident he was in his ability to organize the table and the information that he'd stumbled upon. That he knew more about an element that hadn't been discovered yet than the scientist who discovered it. It's absolutely crazy. Now, before I get too much further in here, I do want to mention one of my favorite anecdotes, which is also just a reminder that, you know, we glorify people in our history classes and our science class and stuff like that. But remember, these people are people, so they're not necessarily the best people. Mendeleev was married, and his wife was good to him by all accounts that I have seen and read. But at one point while they were getting married, or while they were married, he invited his niece over. And his niece came over with one of her friends, Anna Pompanov. I don't remember the exact name that she has, but her name was Anna, and it was his niece's best friend. She was about 16 years old. Mendeleev, I believe, was in his 30s, maybe. Don't quote me on that. And Mendeleev was so stricken by this girl that he became obsessed with her and started writing letters to her and trying to talk to her, buying her things and stuff like that. And his wife obviously was not happy about this. And it got to the point that he divorced his wife and married his niece's 16-year-old best friend, which is messed up already. Like, that's pretty messed up. But also you have to remember this is the 1800s, and like just divorcing your wife is like a pretty big deal. That actually was a crime. It's called bigamy back then, and you could actually like go to prison for that. Like that is not allowed. But the Russian Tsar, at this point, Mendeleev was so far along in his career that the quote that he said in response to that was, "Well, Mendeleev may have 2 wives, but I only have one Mendeleev, so we're gonna let it slide." And he literally just ignored that law for Mendeleev. He allowed it to happen because he knew that Mendeleev's mind and his contributions would be so important to science that he let it slide. Now, this is not on the scale of some other scientists that have done some pretty horrible things, but this is just a reminder that we can really look up to the work that he did, but we can separate that from the fact that he was actually maybe kind of a garbage person. So he called his theory that elements will repeat their properties in a pattern after a while periodic law. And you may have now just realized that you don't actually know why it's called the periodic table, because like that's the name of it, but like why is it called that? And this is why. He said that in this context, periodic is meaning repeating over a period of time. After a certain period has passed, it will occur again. This is why we call it the periodic table. Properties repeat after you've gone a certain distance to the table and you've looped back around to that same position again. That's where the name comes from. More specifically, or scientifically, periodic law states the physical and chemical properties of the elements cycle in predictable patterns based on their atomic number. And again, he's the first dude to do atomic number. Everyone else was trying to do masses back then. And there's actually positions on the periodic table where that does not work. There's actually certain positions where masses do not go in order. So let me click back here and let me find. If only we had like editing, I could, have done this ahead of time and made sure that I didn't do this. Where is it at? Might be faster if I actually just look at the periodic table. Now we get this awkward pause as I try to find my periodic table that I have labeled. Okay. No wonder I couldn't find it. It's not on that periodic table. So if you have my version of the periodic table, or if you just find another version of the periodic table, you can go and you can look, and there is a couple of places where the mass actually does not go in order. You would think, well, if it's going by atomic number, it should still be by mass, right? But there's actually a couple of places that does not occur. So for example, if you look on your periodic table, and if you look over here on the right-hand column, and if you find iodine, tellurium and iodine are actually positioned flipped by their masses. If you were going by masses, it should go to iodine, then tellurium. Tellurium has an average atomic mass of 127.60. Iodine has an average atomic mass of 126.90. Even though it's later in the table, it still has a lower mass. And that's okay by Mendeleev's law. That's okay by the way he set up the table. Other scientists did not think that that worked. They had issues with their table because they were just trying to list them by their masses. And there are some cases where the common forms of things don't go in order of atomic number. Now, keep in mind that we kind of have glossed over this, but I'm going to flip back to what I said a little bit ago when I was talking about that story with Mendeleev and his niece's friend. This was in the 1800s. They did not really have an idea about a nucleus or a neutron. I mean, the idea of an atom was still kind of being fundamentally developed as to what that meant at this point. So the fact that like he was going by atomic number isn't actually what he was doing. He was really arranging it by properties. The guy who actually arranged it by atomic number is a little someone else, but we may talk about that later on. I don't want to confuse you guys. Okay, so that's my background of the periodic table. We're going to pick up here talking about actually reading the table in the next video. In the meantime, this has been Mr. Diamond. If you have any questions, please send me an email. Otherwise, hope you have a good rest of your day. This is Mr. Diamond signing off.